like so. All right. So this is a good article from Ryan Fleury, um, and he's brought up something that I've thought about in the past, but never really like mentioned. I guess. Let me get the. Go. So we have these tools that we build for ourselves as programmers, right? Um, we have the ability to kind of like enable ourselves to create the things that help us to create things. So in this case, you could think of it like uh, IDEs, right? So if you're going to use a development environment, who builds the development environment? Well, that's going to be another programmer. And the intent behind that is um, to enable you as another programmer to create more code for somebody downstream, ideally like a user. And what Ryan kind of touches on here is that we are our own users, and there is a cost that begins with, let's say, inefficient or poor code, or somewhere along those lines. It begins with us. We're actually kind of shooting ourselves in the foot, so to speak. So I'm gonna read this. I usually just pick an article or two to read to open things up, and then I'm gonna go into a few papers, just to kind of touch on a few different points as to issues that are that do not that people do not seem to want to address. At least not the majority. The industry as a whole just seems quite happy with the status quo, for what I think are obvious reasons. Um, so we'll get into it. Programmers are users. Bad performance makes everyone less efficient. On the often referenced notion of saving programmer cycles at the expense of CPU cycles. So right away, you can see that Ryan is talking about something very much in line with what I've been talking about, which is we're trying to save programmer cycles. That is like how much effort a programmer has to go through to accomplish the thing. And we do so because it's easy to say, well, even if it costs more in terms of CPU cycles, it's an acceptable cost because you save on the programmer cycles. So let's get into it. And of course, he begins with Bob Martin, which is not controversial at all. No controversy there. I want the act of programming to be easier, more pleasant, and more productive for the vast majority of programmers, and I am willing to sacrifice performance in order to achieve that. This is probably um, this is probably one of the most short-sighted views I can think of having on just about anything. Um, happiness on the job and pleasantness and all of that definitely helps. Okay, it's not like there's zero value in this, but let me try this from a different angle. We have gone way too far into the sacrifice performance. How about that? How about my argument is we've sacrificed too much performance to make programmers happy? How about that? There's a pervasive idea in the software industry that's often posed to defend abstractions and software layers which are easily and often used to generate tremendous amounts of bad code in favor of programmer efficiency in generating that bad code. When I say bad code, I don't refer to what the programmer sees in his text editor. I'm talking about the actual code, that is, what the user's CPU executes. And so right away, we're touching on indirection or abstraction or obfuscation. So the code that is being executed on the CPU is not necessarily the code you're writing, but a lot of people don't know how to do that translation layer, myself included in many cases. I'm trying to learn it, but many people don't even. The argument goes, given these abstractions or layers, maybe they're language features or programming paradigms, programmers can be more efficient in generating bad code, which accomplishes the same meaningful work as the alternative case. Now, I think you could actually substitute bad code in this argument for just any code. It doesn't have to be bad. Any code, abstraction layers or whatever paradigms that can generate any code which accomplishes the same as meaningful work in other code, right? But in this case, I think he and I would agree on what bad code means. Where the programmer does not use these abstractions or layers and perhaps produces good code, but was more inefficient in doing so. The claim, the hypothesis, or as it is often used, the assertion, it is an assertion, is that these paradigms, abstractions, languages, language features, and so on, are more efficient from a business perspective, at the expense of efficiency from a software quality perspective. And a business perspective could be anything like we accomplished, we created and released certain features. I don't know, we fixed some bugs. Even that could be business value in some cases. But business perspective can mean a lot of different things, but it's usually man, I'm sorry, my throat. One sec. Business perspective is usually put in place of like over top of technical debt. So you're unlikely to tackle technical debt before you're going to tackle whatever the business perspective is on value. And so there's a software quality aspect that gets diminished because the business perspective takes precedence. I recently saw this argument manifest in practice, when I finally watched Ginger Bill's video breakdown of the written discussion between Casey Muratori and Robert Uncle Bob Martin on the technical merits of clean code. It's important to understand that clean code doesn't refer to clean code. Capital C clean describes code in the same way that Democratic People's Republic describes North Korea. It is a label. It has as much information content as a person's name. Bill correctly identifies this and says that it'd really be more appropriately be called Mr. Martin style. And I agree. It doesn't really have much meaning behind besides just being a label. In the video, which I recommend watching, Bill mostly doesn't focus on the technical side of the discussion, and with good reason. As Bill demonstrates, Robert Martin didn't focus on the technical side of the discussion either. Mr. Martin instead opted to debate rhetorically. It's rhetoric, but rhetorically maybe. Bill correctly likens this to being akin to a form of political maneuvering because that's exactly what it is. And here's why it's rhetorical. It is rhetorical because these kinds of assertions that a paradigm, library, language, framework, or whatever that makes programmers feel good about what they're doing, cohesion and synergy and synchronicity and all that stuff, it's based on feelings. And that is rhetoric. Rhetoric its purpose is primarily to make you feel, not make you use your brain in a logical sense. So it is absolutely rhetoric. Throughout the debate, no technical questions are satisfyingly answered by Mr. Martin. If that is what you're looking for, you'll be disappointed. It isn't named clean, rather than Mr. Martin style by accident. I'm going to let the stupid sirens pass. Hey, Laugh, how are you doing? This convenient word choice is often used by clean code proponents to mask unfalsifiable assertions in order to justify certain clean code guidelines by subtly shifting between clean and clean throughout a discussion. Casey and Bill both did an excellent job, But in both the written discussion and the video breakdown, I kept having a recurring thought that I didn't see directly expressed by anyone, and that's why I'm writing this post. You could spend several careers researching programmer productivity. The interface of programming is, of course, tightly intertwined with programmer psychology, the programmer's ability to reason, and the programmer's ability to easily express computational effects. Not all interfaces are equally efficient for programmers to use. Not all interfaces can have equally efficient implementations. Barely investigating this subject leads to the conclusion that some interfaces are simultaneously better for the programmer and better for the CPU than others. Programmer efficiency and CPU efficiency are not always mutually exclusive. One does not necessarily need to always pick one. Unfortunately, serious investigations of these topics are seemingly never carried out by clean code proponents. Claims of improved programmer efficiency at the expense of CPU efficiency are mere assertions. And it's not, see, clean code buckets inside of it a number of other things, including things like React, for example. It could fall under this premise. Other languages like Rust might also fall under this bucket of the assertion that if you spend enough CPU cycles, you'll get better programmer efficiency. But in this post, I want to zoom out from those investigations. I want to give clean coders the benefit of the doubt. Let's say that we are operating in a space where we must trade CPU productivity for programmer productivity. Let's say that we even have tools which we know trade CPU productivity for programmer productivity. Never mind the fact that these premises are never proven to hold. Let's say we find a case where they do hold. I'd like to explain why, in that context, it still doesn't make sense to overwhelmingly prefer the comfort and generative productivity of the programmer writing the code. Even when I've given clean coders everything they could possibly ask for, everything they attempt to assert, there is still a strong argument in favor of software performance at the expense of initial programmer performance. Part of this argument has to do with the overall quality of the computing system, but it is not strictly altruistic. There is also a strong business case for software performance, even with heightened upfront programming cost. I mean, he's basically saying all the things I've been saying since I started streaming. As such, this argument does not require that you have business inclinations, nor altruistic inclinations. You could love or hate the concept of a free market with private property. In all such cases, this argument still applies. Casey did say that in one of his videos. Yeah. The fundamental mistake I see as responsible for entirely destabilizing the argument in favor of programmer code writing efficiency at the expense of software efficiency is an incorrect model of the software ecosystem. Programmers run their own code. The implicit model being used to justify the trade-off assumes a single software producer which produces the code and a single customer which executes the code. So here you go. You have someone who produces some code, it then gets shipped out, and then the user runs that code. But this model ignores the everyday reality of programming. The reality is that the producer must also execute the code as they develop, debug, and test it. Only after they're done that process, only after they've done that process innumerable times, they will submit the software to the user to be executed. And so this is the reality, because you're writing your code and then you're testing it and rewriting it and fiddling around with it until you get it right. Then you release it. And if you have stages before your release, there could be many steps here instead of just the one, right? So you might be testing it again on a pre-production staging site, development site, whatever it is, running it over and over again, and then you pass it off to the client, who then runs it over and over again, and rinse and repeat. Already in this model, bad software execution time has already caused a slowdown in programmers' productivity. Some amount of the programmer's efficiency in reading or writing the code has already been counterbalanced by the software's inefficiency because the programmer is blocked on executing his own software. The slow software execution time has thus had an impact on the programmer's iteration cycle time. Mr. Elfman on Twitch, I'm dealing with this right now. I have to wait 2 minutes for something to link. Right. And so this is the problem that comes with utterly contemptible, disgusting, putrid shit like React, where compiling your front end breaks the entire cycle of what we've had that's worked so fantastically well for such a long time, which is you make a change, you hit refresh, there's your change. And even a programmer efficiency in terms of reading or writing the code can still be overcome in a space where it's not so easy to read or write the code. When you're adding complexity and layers and abstractions over that, what you're doing is all you're doing is kicking the can down the road. You're actually not solving anything. It's exactly the same argument as, well, I am too intimidated to use CSS, so I'm going to use Tailwind. So in order for you to write CSS, you're just kicking the can down the road. You're going to bring in JS and a build system, and then you're going to write CSS. To continue justifying the choice to prefer programming methodologies which promote fast generation of bad code, one must prove that this degradation of programmer iteration cycle time does not outweigh the improvement in programmer efficiency in generating the code. Given that code can often be written once, but tested, debugged, and tweaked hundreds if not thousands of times, this fact is important to demonstrate, but it is never demonstrated. This is more low level than React. It's a WASM linker. Oh, I see, Mr. Elfman. Yeah. But having a build step makes me feel like a real programmer. Right. And I think this is one of the things that I don't think front end people will admit. But I think deep down inside, they know this is true. Doing something like compiling your front end is just a way for front end programmers to feel cool as the kids they looked up to who were back end programmers who did all the cool stuff on embedded devices and Linux servers. They would look over there. I remember you look over at the people doing the back end, you'd be like, whoa, they really know their stuff. I'm just over here moving pixels around. It's like, well, how are we going to make ourselves look as good as they are? Compile your front end. I mean, I think we just have a lot of poorly made tools. Yeah, Hyla, we do. By the way, hi Hyla. Hi, Mr. Elfman. How are you doing? We would probably solve a lot of this problem if web devs admitted they weren't real devs. Yeah, I think that would be good. I mean, maybe not. Maybe they are. Yeah, we're the jokesies, okay, but I do think that they do. There is a sense of we feel good because of the complexity we have to tackle on the front end. Right? It makes us feel good. It makes us we can compare ourselves to the people who have had to deal with that complexity on the back end or in other systems that we couldn't understand because we're front end people, right? There's something about web dev or web adjacent programmers like my ordinary linker works fine. I don't know, man. I think it's bizarre to introduce a build step to something that doesn't need one, like a preprocessor for Lua or something. Save and run is instant. It's so good. Yes, I don't think you need. You should be asking yourself, why do you need a build step? How far have you strayed from you used to just be able to just change code and hit refresh and you're done to now you have to go through X number, N number of steps to compile your code? Why? I think if you are honest with the answers, the reason why does not always hold weight. If you really need a preprocessor, maybe you're using the wrong language, possibly. Yes. Okay, customers are programmers. But This problem gets worse. Who is the software producer? What are they making? Who is the software consumer? What are they using the software for? It seems like clean code arguments are often made assuming a very narrow definition of these two entities. For example, as used in the original written discussion, some payroll software used by a business to pay employees. But what is the common reality in the software world? Let's take an example from the real world, from my own life, in fact. I work on a debugger project full-time, the RAD debugger. As part of my work on that project, I need to use a file explorer. The Microsoft Windows built-in file explorer is a flaming pile of shit. It's an incredibly poor quality experience for a large number of reasons, probably related to clean code, in fact, which is why I'm excited for my friend. I'm not going to pronounce that because I'm going to butcher it. I apologize. A file explorer project, file pilot. He is a programmer too, and so as part of his file explorer project work, he needs to use a debugger. Hang on, what's going on? You should RadDB to let the audience understand how cool RadDB. I'll do it after, yeah. Hey Travis, how's it going, man? Good to see you. The dingus has landed. If you're pre-compiling something like Lua to VM machine code, the reason is going to be performance, skipping the interpretation step, as well as presumably that code being a smaller package, so better content size management, which are all things we talk about around here. Fair point, Arvis. Okay, fair point. I guess if I would have to then restate the argument as, why do you need to introduce a build step in the world of web development that you didn't really need? Like, you should be asking yourself, do you need it there? Good luck debugging your Lua build step when it breaks horribly. Okay, I'll let you guys go at it. I'm going to keep going. Instead of some arbitrary payroll software producer and some arbitrary business, let's say the entity on the left is me writing the debugger, and the entity on the right is, oh man, I'm going to have to pronounce it, Vyacheslav, writing his file explorer. This is a slight extension of the initial oversimplified model. It demonstrates one simple case of cyclical dependencies within the software ecosystem. This is an overwhelmingly common relationship. It regularly manifests within a single company or organization, but it extends beyond those boundaries as well. So this includes scaling up, right? So we can take into account what happens when you have a large team size. So now what happens is you have the debugger over here, and Ryan has to waste time on CPU inefficient cycles to get the debugger to work. Then the debugger is used by Vyacheslav, who also has to use the debugger in order to figure out what's going on with the produced code. So now you've got this like stack, like, you know, it's growing almost quite fast. The number of CPU cycles wasted. The idea that this is ultimately faster than, yeah, because the way that you read and write code is more efficient, already to me sounds like a steaming pile of bullshit. Hey, Mystified. In this context, if my software is unnecessarily slow, not only does it slow myself down before I release it, it also slows Vyacheslav down in his development. This degradation in his programming performance manifests in fewer iteration cycles for his software, which I also depend on. Because I began by making my software worse than it could have been, that effect has propagated outward into the computing ecosystem. And because the computing ecosystem is a cyclical graph of dependencies, that effect propagates back to me. And now I want you to think about what this means in an ecosystem where you're using a library, like it could be React, it could be Vue, could be maybe Svelte, where you have interdependencies. You cannot use the library by itself. The library necessitates that you import other libraries. So it's like the NPM thing or Rust crate thing, things like this. What happens when you introduce other external inefficiencies that other people have built? And then your argument at the end of the day is, well, I'm wasting a bunch of CPU cycles, but my code for me feels much easier to manage. I don't even know how you could quantify such a thing. Nor do I think that if you did quantify it, the proof would bear out that you're saving time. I think the proof would bear out that you're wasting time. Slowness propagates, then compounds. And not just slowness, by the way. I would add also security vulnerabilities and other issues. But this problem is worse still than I've described. A more detailed graph of the software ecosystem is more complex than the earlier examples. The software ecosystem is a vast, cyclic network of interdependent entities producing software and relying on other software. You can even think about, if you're deploying something to the web, for example, you can even think about the software that runs on the hardware upon which the website is being served from, right? Like every individual point of the life cycle of anything you're producing suffers from this problem. Poor performance introduced at points in this network propagate outwards because depending on software means executing that software. Execution time of an entity's dependency is, one way or another, factored into the production of the dependent itself. This may be literally execution time in the dependent software, if it relies on a poorly constructed library, or it may be in programming resources if the programmer relies on a poorly constructed tool. Whether it blocks the programmer or the software, it has a cost. The longer the dependency chain becomes, the more likely these effects will be multiplied or otherwise duplicated, and the more likely that these effects will back propagate to the dependent software. Not to mention that the longer this dependency chain becomes, the less likely that anyone will understand what the problem truly is or how to fix it. And this is another key point, which is, again, you're kicking another can down the road. You might upfront, I've been saying this for like the longest time. I have been in rooms where the company has hired React developers who have either like started learning React or are very good in React. And it doesn't happen often. I got to be honest. It happens once in a while. But I can think of at least 2 occasions where the team hit a wall with React on a project we were doing. React could not do the thing we needed it to do for a website. Hey, Sid on YouTube. How's it going, man? Good to see you. Thanks for being here, man. And you're looking around at a room full of React developers who they generally understand React. And so you're, I remember an executive came in because one of the clients was screaming at us, and the executive came in and he's like, so what are we going to do about this problem? What's going on? Of course, he doesn't understand the technical jargon. So there's some back and forth. And then essentially it boiled down to, well, we don't think React can do the thing we need it to do. And myself and one other person, we were like the graybeards and at the time. And I was pretty young, so it's kind of sad that we were the graybeards. We had to go and dig into the React source code to figure out where exactly the problem was and fix it with an escape hatch using vanilla JavaScript. And so this is the problem with the dependency chain, where I think someone said it in chat, Hilo Blocks, React has 97 dependencies, right? This isn't just React. This could be many other libraries, languages, frameworks that have this dependency chain. You're paying a cost in terms of execution time because you don't know how performant it is. The abstractions, the paradigms, the obfuscations necessarily mean that you're highly likely to be less performant. And when an actual problem arises, that problem is much bigger due to the dependency chain than without it. The likelihood of that is high. Even if you want to take like a I don't know, a conservative approach to this, maybe a more charitable approach, and go, well, it doesn't always mean this. Okay, but how high are you increasing the likelihood that those things are going to like completely block you from moving forward? And what have you actually saved? And so this is what it actually looks like. I'm going to zoom out a little bit. I mean, I could basically just like write npm, or webpack, or import modules or whatever on the web, or compilation steps with React Native. Who knows how many dependencies that you're obfuscating, running a React Native mobile app. Same with React Server Components. What else could you say? Node, on the back end, it's Node could do this too. You npm install with Node or Bun. How many dependencies do you have when you're running Bun? Python. How many dependencies do you have in Python? All of these things have a cost. And the question is, how do you identify the cost of the poor execution, the security vulnerabilities, the issues that come up, the fact that you don't understand what those issues are because you don't actually understand the things you've pulled in, etc., versus the quote unquote benefit of, well, I get to read it and use it easier. It makes me feel good. This reality has explanatory power in describing the state of modern software. Despite vast improvements in computing hardware capabilities, some software often performs dramatically worse than its contemporary equivalent running several decades ago on hardware that was sometimes 1,000 times slower with 1,000 times fewer resources. This is because poor performance in this network does not stop at one edge in the network, it is multiplied several times over. You are amplifying the effects of shit. During the initial discussion, Mr. Martin introduced several time domains. He described some problems as being within the nanoseconds domain, where wasting nanoseconds matters. He described the microseconds domain, where wasting microseconds matters. He described the milliseconds domain, where wasting milliseconds matters. The problem is, however, that there is only one time domain in reality. And wasted nanoseconds add up to wasted microseconds. And those add up to wasted milliseconds. And those add up to wasted seconds. This can happen before network effects in the software ecosystem are considered, simply within one piece of software. And what's interesting, Chris Griffin, another streamer, he put out a tweet or a post on LinkedIn or something earlier today, and he said something along the lines of, I don't understand why people feel like have kind of like a rosy view of developers in the past. Think about Y2K. Those programmers in the 70s and 80s were so lazy, they were trying to save a couple of bytes, and then it caused the Y2K issue because you didn't have enough space to fill in the time. So when 1999 rolls around and those bytes, are now, well, biting you in the ass. Here's the problem. What Chris doesn't get, and what many people don't get, is that these look like small things when you look at them in a small way. But 10 million single bytes is 10 million bytes. 100 million nanoseconds is not just one nanosecond after the other. It's 100 million nanoseconds, which you can scale up to microseconds and milliseconds. I'm not going to do the math in my head. Okay, so these have a cost. And to say, oh, it's just a nanosecond, who cares? It's just like 100 milliseconds, who cares? No, everyone cares, including you. And it scales up in this context, the bigger your team size is. The more users you have. These things scale up. It matters. That's a bad take. Those optimizations were required back then because of resource limitations. They weren't lazy. Devs now are lazy. Correct. I think Chris is absolutely Chris is absolutely dead wrong about that. That's a pretty brain dead take. It's just a brain dead take. Today we have the space because hardware has improved. In the 70s and 80s, that hardware did not exist. It was a limitation of resources, not because these people were lazy. But even still, the point is saving a couple of bytes is not just a couple of bytes in a vacuum. You can't look at it that way. A couple of bytes multiplied by usages scales up exactly like this argument, right? After network effects are considered, it is perhaps no surprise that programs now accomplish in 30 seconds what they used to accomplish in less than a second on hardware which was thousands of times less capable. Spending software efficiency to obtain programmer efficiency may seem like an appealing idea, but I hope this post helped clarify why it isn't that simple. The acceptance of software production methodologies, like the one Mr. Martin himself promotes, are in part responsible for a vast degradation of software quality and, ironically enough, decreases in programmer efficiency. I open this post with a quote from Mr. Martin himself. I want the act of programming to be easier, more pleasant, and more productive for the vast majority of programmers. Unfortunately, the act of programming is harder, less pleasant, and less productive than ever because of systemic excuse-making for mediocrity. Sacrificing software efficiency for programmer efficiency seems to simply result in losing both. Yeah, no one's happy. Not even the people who are using the things. That's right.